Hey everybody, Mr. Troy here. I'm going to take a crack at one of the problems from your homework, problem number 33. Now, you are going to have different numbers here in the constant column. However, all of your coefficients are the same, so you should be able to follow all the same steps. For that reason, I'm not going to show any of the arithmetic. I'm just going to say what I'm doing. Okay? All right, here we go. The first thing I did was I wrote the matrix or the system into an augmented matrix. Okay? And I'm just going through and I'm checking to make sure that what I originally had written down, I wrote down all of the correct coefficients, because it would be awfully silly to write something down and do it incorrectly. Okay. From there, I am going to swap the first and the third rows. That way, I'm going to have the easiest time possible and have a 1 in the top left corner. Okay, now just to make sure we're clear what the idea here is, you want to start by eliminating these 3 entries, then these 2 entries, then this 1 entry, and then you want to turn this into a positive 1 in that order. Okay? So it's going to take at least 3 steps probably. Might take more, might take many more. Okay. I've rewritten it here so that things are a little bit easier to see. Okay. I am going to now eliminate all of the x's. In each of these cases, I'm going to use the top row because there are no common factors between the 3, the 2, and the 5. So it doesn't make sense to use the 4th row to cancel out the 3rd row or what have you. Okay, so here's my result. Now I'm kind of at a tough position because -11, -9, and -23, those don't have any like factors. So what I'm going to do is I am going to I'm actually going to go bigger here. So I am going to multiply. How do I want to do this? I'm the one in control of the video. I didn't have to unpause. Okay, I thought about it for a couple minutes and I think I've decided what I'm going to do. I am going to multiply each of these rows, rows 3 and 4, I'm going to multiply by -11. So I'll do that and then I'll explain why. Okay, so there's what I got. And the reason I did that was so that I could use row 3 times, say, 9 to cancel out, or sorry, row 2 times 9 to, say, cancel out row 3. Because remember, what we're aiming to do here now is cancel out these 2. Okay, I'm going to rewrite and then we'll move on. All right, so I am going to take row 3 and I'm going to add 9 times row 2, and that's going to be my new row 3. So I'll have 99 and -99. And then I'm going to take row 4 and I'm going to add 23 row 2, and that's going to be my new row 4. 23 times 11 is 253. Okay, the fact that I got a 1 here ends up being pretty much the best news of the day, because it means that I can immediately just go straight into adding 17 times row 3 to row 4. And I don't even have to think about that calculation because I've already got that 1 there. That is great news. Okay, I'm going to copy this onto a new page, and then we are almost home free. Okay, like I said, I'm going to add 17 row 3 to row 4, and that's going to be my new row 4. All right, so some of the arithmetic is maybe not that great, but we did just get into a situation where I can tell that W is -2. All right, so I'm going to multiply by, 1 over negative 781 times row 4, and that's going to be my new row 4. All right, so I did that. Here is my row 4. And the next thing that I'm going to do is I'm going to add 43 times row 4 to row 3, 17 times row 4 to row 2, and -6 times row 4 to row 1. That's going to allow me to turn those 3 entries, the 6, the -17, the -43, into zeros. All right, so now I have my last 2 variables solved for. My z is 4, my w is -2. Okay, and my next goal is to eliminate those 2, and I'm going to do that by throwing row 3 into them. 6 times for row 2 and -2 times for row 1. Okay, if you've gotten it this far, you could actually probably solve the rest of it in your head, but let's not be silly. We're going to multiply row 2 by -1/11th, and then we are going to add -5 row 2 to row 1, which would look like that, and it would give us the following as our answer. So here it is as a matrix. And then as an ordered quadruple, it would be 0, -1, 4, 2. There we go. It took me a while, but I got it. That's a pretty cool problem. I think I like it a lot. Hope that helps everybody. If you happen to have those same numbers, you're in luck. If not, you can follow all of my red steps and you should get to the same place. Have a good one. Bye.